Hello, my name is Kirti. In this video, I am going to talk about the most underrated law of thermodynamics, that is zeroth law. So to many students, this law appears very simple and all of us take it for granted. But trust me, this is the most important law of thermodynamics. Because if nature did not obey this zeroth law, it would have become really difficult for us to study thermodynamics of any system on this earth. Okay. So in this video, I will first discuss the definition of zeroth law, and then we will further discuss what is the significance of this zeroth law as far as thermodynamics is concerned, and we will also discuss what would have happened if nature did not obey this zeroth law. Okay, so stay tuned. But before we move for the definition of zeroth law, we need to know two terms. Okay, the first term is temperature. And the second thing that we need to understand is thermal equilibrium. Okay? Thermal equilibrium. So to understand zeroth law, you need to understand these two things. So I will take the vague definition of temperature, which says that temperature is the degree of hotness or coldness of the body. Okay? So temperature is the measure of degree of hotness or coldness of the body. Measure of degree of hotness or coldness. Hotness or coldness. So this tells you which body is more hot or which body is cold relatively, right? So this is temperature. Suppose if the temperature of some object is 50 and some object is 25. So that means the object which has 50 degrees centigrade temperature is relatively hotter than this object. Okay. Now let us understand what is thermal equilibrium. Okay. So to understand thermal equilibrium, consider two objects. I will name it as object A and object B. Okay. Now suppose the temperature of object A, that is T, is TA, and temperature of object B is TB. Now if I suppose that TA is greater than TB, that means temperature of A is greater than the temperature of object B. Okay, now when I bring this A and B in contact with each other, what will happen? So now I brought this A and B in contact. So what will happen? The heat flows from the body of higher temperature to the body of lower temperature. So the heat flows from A to B here because temperature of A is higher than temperature of B. Suppose A is at 30 degrees centigrade and B is at 25 degrees centigrade. Okay. So heat flows from A to B. How long the heat will flow? The heat flows until the temperature of these two objects become equal. Okay. So heat flows until the temperature of A becomes equal to the temperature of B. Okay. So suppose if the temperature here is 27 and here is also 27. Now the temperature of A and B are equal, then there will be no net transfer of heat energy between these two objects. No net transfer of heat. So this condition is called thermal equilibrium. So what is, excuse me. So this condition is the thermal equilibrium condition. When there is no net transfer of heat between two bodies which are in contact with each other, then that situation or that condition is called thermal equilibrium. Now here I am not saying that there is no transfer of heat. I am saying that there is no net transfer of heat. Okay, let us understand what it is. Even at thermal equilibrium, there will be transfer of heat between A and B. But the transfer of heat between A to B and B to A will be equal. So if the transfer of heat between A to B is X, the transfer of heat between B to A is also X, because at thermal equilibrium they are at same temperature. Okay. So what will be the net transfer of heat? Transfer of heat from A to B minus transfer of heat from B to A, that is X minus X, that is 0. So that at thermal equilibrium, there is equal amount of transfer of heat between A to B and B to A. So there is no net transfer of heat, right? So this condition is called thermal equilibrium. Since you know what is temperature and thermal equilibrium, we will move on to understand what is zeroth law of thermodynamics. Okay. So the zeroth law says if the object A is in equilibrium with object B and object B is separately in thermal equilibrium with object C, then object A and C will also be in thermal equilibrium with each other, right? So we will see what it means. Suppose if I have an object A which is at temperature TA and object B at temperature TB. Suppose temperature of A is greater than B, and if I bring A and B in contact with each other, what will happen? Since temperature of A is greater than temperature of B, there will be transfer of heat energy from A to B until this thermal equilibrium is established, right? So, transfer of heat energy takes place until temperature of A becomes equal to temperature of B. Okay. So there is a thermal equilibrium between A and B. So this is the first condition. Now suppose that temperature of A and B is equal to 25 degrees centigrade. Now next what I do is I take this B from here and keep it in contact with C. So here I kept B in contact with C. Suppose if I see no transfer of energy between B and C when I bring them in contact with each other, then what does this mean? This clearly means that B and C are already in thermal equilibrium with each other, because there will be no net transfer of heat energy only when there is thermal equilibrium, right? So when I brought B and C in contact with each other, I do not see any transfer of heat energy between B and C. That means B and C are already in thermal equilibrium. So this is the second condition. Now when I bring this C in contact with A, so here temperature of B is equal to temperature of C. Now can you guess what is the temperature of C? You can easily guess, because we know that temperature of A and B is equal to 25 degrees centigrade. Here we know that temperature of C is equal to temperature of B. Then temperature of C must also be 25 degrees centigrade. Okay. So even without checking it with thermometer, you can predict the temperature of C as 25 degrees centigrade because it is in thermal equilibrium with B. So this is the beauty of zeroth law of thermodynamics. So it doesn't end here. Now when I bring A in contact with C, because the nature obeys this zeroth law of thermodynamics, there will be no net transfer of heat energy between A and C. That means A and C will also be in thermal equilibrium with each other. So we know that temperature of A is equal to B, B is equal to C. The temperature of A is equal to temperature of C. Since the temperature is equal, there will be no net transfer of heat energy. There will be no net transfer of heat energy between A and C. The temperature is equal, so their degree of hotness or coolness is also equal. Now let us see what would have happened if nature did not obey the zeroth law of thermodynamics. Okay, so because nature obeys zeroth law of thermodynamics, when A is in equilibrium with B and B is in equilibrium with C, then A will also be in thermal equilibrium with C. Okay, but if nature violated this law, so if zeroth law was violated, what would have happened? Let us see. So if zeroth law was violated, if there was equilibrium between A and B and C, even then there will be no thermal equilibrium between A and C. Okay. So this would have happened when nature did not obey zeroth law. So what does this mean? So here we know that temperature of A is equal to the temperature of B, which we saw as 25 degrees centigrade. And here we know that temperature of B is equal to temperature of C, which is also equal to 25 degrees centigrade. So from these two conditions, we know that temperature of A will be equal to temperature of C. So here, temperature of A is equal to temperature of C, but there is no thermal equilibrium between A and C. What does that mean? That means there is transfer of heat energy either from A to C or C to A, right? By heat energy, I mean transfer of heat energy means net transfer of heat energy, okay? So no thermal equilibrium means there is net transfer of heat energy from either A to C or C to A. So here, even if temperature of A is equal to temperature of C, there is no thermal equilibrium between A and C. No thermal equilibrium means there is transfer of heat energy either from A to C or C to A. So when this will happen? This will happen if the amount of heat in A is not equal to amount of heat in C. Okay. So let us suppose that there is Q1 amount of heat in A and Q2 amount of heat in B. Okay. But we know that the temperature of A is equal to C, which is 25 degrees centigrade. So temperature is 25 degrees centigrade. Here also the temperature is 25 degrees centigrade. So here you see that Q1 amount of heat in A leads to 25 degrees centigrade, but Q2 amount of heat in B leads to 25 degrees centigrade. That means Q1 amount of heat in B will not be equal to 25 degrees centigrade. Sorry. Q1 amount of heat in B will not be equal to 25 degrees centigrade because Q2 amount of heat in B is 25 degrees centigrade. And Q2 amount of heat in A will not be equal to 25 degrees centigrade because Q1 amount of heat in A is 25 degrees centigrade. So that means the temperatures are equal but the heat content is different. That means that this temperature is no longer the measure of heat content, right? This temperature is the measure of heat content only in A. This temperature is the measure of heat content only in B. So that means every object will have its unique temperature scale if zeroth law was violated. Okay. So you need to have a different temperature scale for A, you need to have a different temperature scale for B, you need to have a different temperature scale for C, right? So now suppose, now imagine there are maybe greater than 110 elements in periodic table, right? And all the elements should have their own temperature scale. We cannot have this unique temperature scale for all the objects. Now we have unique temperature scale for water, oil. You can use the same thermometer to measure the temperature of water, to measure the temperature of oil, to measure the temperature of any other solution, right? But if nature violated the zeroth law of thermodynamics, you cannot use a universal temperature scale. You need to have a different temperature scale for different materials, right? Because here we see different amount of heat leads to different temperature in different objects. That means every object will have its unique temperature scale. Now there are more than 110 elements in periodic table. So there will be the compounds, like different combinations of elements make compounds, right? There will be the compounds, alloys. There will be maybe nearly lakhs of materials on this earth. Okay, and each material will have its own temperature scale. So now imagine how difficult it would be to study the thermodynamics of any system using a different temperature scale every time. First, we need to establish a temperature scale for every material. Is it possible? So this you can use a universal temperature only because the zeroth law of thermodynamics is obeyed by nature. If nature did not obey the zeroth law of thermodynamics, you cannot use this universal temperature scale. You have to use a different temperature scale for different material. Okay. So this is how important this zeroth law of thermodynamics. It helps us to establish a single temperature scale for all the materials on this earth. Okay. I hope you have understood the importance of zeroth law, and here onwards you will give its due credit and you will not take it for granted. Thank you so much. See you in the